what we're being asked to do here is to differentiate this thing here. This is determine f dash x. Determine when f dash x equals 0, that might be used for turning points. Determine f dash x equals 2, so where the gradient is 2, and then also to determine the gradient at f equals negative 1. At x equals negative 1. So the things we're going to do now. Because we're dividing two functions, we need to use the quotient rule, which is v times du minus u times dv over v squared. So that's what we're going to do. So the top, we have u, the bottom, we have v. So then from there, we say that du equals 16x cubed minus 24x, and dv, and we know dx, du, dx, dv, dx, I'm just writing it save space, and dv equals 24, whoops, not 24 at all, dv equals 3. So then from there, we're going to substitute this and this into these. So v du, so we're going to have 3x, because that's v, times by du, 16x cubed minus 24x minus u dv, which is 4x fourth, 4 to the power 4 minus 12x squared, and then multiplied by dv, which is just end up being 3. And we put all that over 3x squared, which is 9x squared. Okay, so from there we expand and simplify. So 3x times 16x cubed, we end up with 48x to the power of 4. 3x times 24x minus 72x squared. Over here we're going to multiply this 3 by what we've got inside there. So we'll have minus 12x to the power of 4 plus 36x, and that is all, it's x squared. That's all still over 9x squared. So then we simplify this further, and we've got 36x to the power of 4 minus 36x squared over 9x squared. We can take out a common factor of 9x squared rather, and we'd end up with 4x squared minus 4. So 36 divided by 9 gives us 4. X to the power 4 divided by x to the power 2 gives x to the power 2. 36x squared divided by 9x squared gives us negative 4. So that is our derivative. That's what we've got there. Okay, so now that we've got our derivative, I'm just going to move this around. It'd be cool if I could do that on a whiteboard. And that's our derivative. So now we want to find where does the derivative equal 0, where does the derivative equal 2, and what is the value of the derivative, or the gradient, when x equals 1. So we're going to do those substitutions. So we're going to let the derivative equal 0. So we're going to say we've got 4x squared minus 4 equals 0. So that tells us we've got 4x squared equals 4. Side by side by 4. X squared equals 1. So x equals plus or minus 1. Where does the gradient equal 2? Well, we'll let the gradient equal 2. So we've got 4x squared equals 6. X squared equals 6 over 4. So square root both sides. So we've got x equals plus or minus root 6 over 2. And for the last one, we're just going to substitute negative 1. So we'll have 4 negative 1 minus 4. Now that's squared. So we end up with 4 minus 4. And that just ends up being 0. So we use the quotient rule. Take the bottom, multiply by the derivative of the top. Then we take the top, multiply by the derivative of the bottom, divide all that by the bottom squared. That's what this is here. Then we've got to simplify, expand, do whatever we need to do till we finally reach our derivative. From there, we treat it like a normal derivative. Turning point, where the value, where the gradient, sorry, where the function is a particular gradient, and then what is the gradient at a particular x value.